Welcome back to VTU e-Shikshana program on computer aided engineering drawing. In this session, we are going to discuss hexagonal prism when its base edge on HP and axis inclined at some degree to HP, and again axis inclined some degree to VP. It may be appears to be or direct. So let us take a problem which is identified as a hexagonal prism of 25 mm base edges and axis 50 mm long as one of its base edges on HP, such that the axis being inclined at 30 degree to HP and appears to be inclined at 45 degree to VP. Here, unlike other problems, I have taken directly only one case, and then we will discuss the remaining cases after getting the solution. Now let me start working for the problem. I have hexagonal prism model and I have the light color top face and dark color base. Here these are the base edges and this is corner and longer edges, top face, base. Now he says when it touches with one of its base edges on HP. So we have to keep the base edge to be placed on HP always perpendicular to VP. So we will start keeping the solid in this position perpendicularly and give inclination to the HP. So first position, second position. So I have told you many times, why not like this? Orientation cannot be other than this, because if I do like this, it becomes corner condition, corner on HP, or any random situation also it is corner, because we are giving inclination only to HP, it becomes corner. Unless the edge to be placed on HP is perpendicular to P, we cannot give and normalize the situation. So first position, second position. Whenever you get inclination to HP, always you make it perpendicular to HP axis. Now the top view is true shape, that is hexagon, cross section of the prism. So let me start from top view. Okay. Now we will have the hexagonal shape. So how to draw hexagonal shape manually? So I already explained during the laminate. Here what I do is I will explain that with circle method. Assume that a circle with radius equal to side of the hexagon, these two as centers, draw arcs. Then join these points. So you will get hexagon, and if it is corner condition, what you have to do? Again draw this with very light line. Okay, you should keep, and these two as centers, draw two arcs. So then you get corner condition. So this is how you get the point. So if you want the side, these two as centers, draw arcs. Again with this as center, draw arcs. So here assume that I have utilized this method. In computer you get polygon by center. Now let me have the regular references HVP and have a line perpendicular to it, and also should have to the right side. Even in this case both sides works for you. Okay. Now assume that I am keeping this according to the requirement. So I have taken directly dark lines because top view is true shape and dark lines. Now project all these points. So this is A, left extreme nearest corner. This one is B, C, D, E, F. Then if you project B, that should coincide with E and move further. Okay, now what about the height? Height is 50 mm and the side of the hexagon is 25. So normally to accommodate within the sheet they will give 25 for hexagon. Okay. Now, so you fix the height. So height will be around 50. In this case, it is 50 given exactly. So now the problem is concept of visibility. Okay, concept of visibility is very important here. Many times concentrate on the axis. So now let me see what are the lines to be darkened. This is A1 dash, P1 dash, C1 dash, D1 dash, E1 dash, A, B, C, D. This is E, F. Now A dash, B dash, C dash, D dash, E dash, F dash. So lines to be darkened here is very important. These are two extreme edges, fine. What about this? BB1 is visible, E1 is not visible, but axis is there. Which one to we prefer? As I explained earlier, visible line, then invisible line, then axis, then construction line. Here we have visible line. Majority of the time I have seen people keep only axis. It is wrong. If it is visible line exists, definitely you must keep the visible line. Now draw this. Okay. So this is how you get the front view of the prism like any other problem. Now assume that I have taken twice of this. Now after giving the reference base edge on HP, I have taken C1 D1 to be placed on HP, C1 D1 to be placed on HP, and I have made the axis perpendicular so that the true shape is hexagon with the given size. Now I have to give inclination to the HP by 30 degree to HP. So what you have to do is, you have, unlike pyramid, I will take directly 30 degree to this line. If I give axis, hidden line, imagined line is there, axis. If I give inclination to 30, this also assumes 30. So I will take this reference so that I can rotate about this. In computer, you move and rotate about this for with respect to this line 30 degree. Definitely it assumes 30 degree to the axis. Now what I do is keep 30 degree line first. Manually if you are doing, so keep little away. Then redraw this figure such that C1 D1 is this. It refers to this figure. Draw this one. Now assume that this is the shape I have. Okay. Assume that I have redrawn using the rectangle concept. What you do is, first you mark this distance. Actually this is given 50. Then draw two vertical lines, perpendicular lines using the small protractor or any method, set square. Then take only one distance. That's all. That works for four arcs. Draw arc here. Again with these two centers, draw arcs. Then you will get the figure. Yes. I got the front view redrawn with respect to C1, D1, CD on 30 degree line. That assumes 30 degree to axis. 30 degree. Dark this as usual. To start with only you can dark, but in computer it's easy. Move and rotate. Okay. Now name it A1 dash, B1 dash, C1 dash, D1 dash, E1 dash, F1 dash, A dash, B dash, C dash, D dash, E dash, F dash. O1. O dash, O1 dash. You need not worry about whether to be placed in bracket or not. No, it is only axis reference. Here, actual corners must be placed in bracket. That's all. Okay. Now, again project it downwards to get the second figure top view. So, as usual, you have to project it and get the projections and mark the corners. Now, again, as I told many times, it is the reference for the rightmost corner or a item like this. Keep rightmost projection and bottommost line. This is yes. Let it have some intersection, little bit, not more than that. Now, unnecessary lines you can avoid. Project all these corners. Now, I have clear cut corners A, B, C, D, E, F for the base as well as A dash, B dash, C dash, D dash, F dash. Now, draw projections. Okay, get exactly 3 lines for each laminae. They are assuming that the 2 laminae are there, we are projecting it. Yes. This for the base, this for the top face. Sometimes it may overlap, that depends on the angle. So, if it is 30°, it will be very clear, separate laminae. Otherwise, it will be very close or overlap sometimes. Now, draw these lines. Axis. So, how to get the axis? Try to have this diagonal intersection gets you O1. Already this is common in all the cases. If you want, you name it. Otherwise, now identify the points of intersection. This is very important. Simple also. You get the lines. This one is missing now. Okay. Now, these are the points of interest. This is A1, B1, C1, D1, E1, F1. Here is A, B, C, D, then this is E, F. Then join top face corners and base corners in order. You get the top face and base top view, second figure top view. Now, light lines only you use for all the practical purposes. Finally, you can decide yes, you should get same size and shape because of same inclination is there. Then let me complete the boundary also. Yes, I got the overall top view all in the light lines FF1, AA1, DD1, CC1. Now I am here, I am looking at this object. So what exactly the visibility? Whether the base is visible, top face is visible, let us see. First position, second position. The dark color base is available, light color top face is there. Now edge is on HP inclined. Now I am looking at this. Definitely this is visible. Now let me change the direction 90°, rotate by 90. Assume that this is top view for you. The top face is visible, base is not visible. Okay. So lateral surface is visible. Now you can either use the farthest item from you concept or the key surface concept. Now, better let us say more the number of sides, it is confusing if you go for farthest item from you. Anyway, let me use that method only and work out. Which is the farthest item? C1, D1 is the farthest item. Base, edge C1, D1 is on ground, which is the farthest item from you. That is from observer. Now that one is dotted. See here the item is this. Then comes this particular line has 4 lines connected to that. See, this is E1, D1, D1, C1, B1, C1. These are the lines connected to each other. Now, what I do is, I will try to do this. Say, this. Let me try this. Okay. Now, all remaining lines are dark. All remaining lines are dark. Now, how to do it? See, A, B, C, D, E, F, top face. Boundary line is completely dark. Okay. So, what about AA1 and FF1? Again confusing, because he says other than boundary line, these lines are dotted, that is invisible. But what about FF1? For this reason, it is better to go for key surface concept. Okay. Otherwise, also I can say FF1 and AA1 is very close to the observer. Definitely that particular rectangle is visible. Draw. That's all. Now it has completed. Now what happened to this dotted line? Which one you prefer? Here between F1 and D1 we have 2 lines. One is dotted and dark. So preference should be given for dark line, not the dotted line. That means from this portion to this portion, this is completely dark. FF1 is completely dark, and rest of the thing you have dotted line. Fine. That's all. Otherwise, I can repeat the same using key surface method. Okay. Concept is very clear there. I will redraw this and then tell you the thing. I will keep everything light and rename it. Keep everything light. This is A1, B1, C1, D1, E1, F1. Fine. Now this is A, B, C, D, E, F. Now let us start from the visible key surface method. The nearest key surface is visible, that is top face is visible. First dark it. Dark top face edges. It's very clear cut and narrow method, no confusion. Especially more the number of edges, you have the problem with the farthest item concept. So this is very easy. Okay. First dark all lines of the visible key surface. Then boundary lines dark. Basic procedure 2. All boundary lines are dark. Then think of the invisible key surface. Visible key surface is over. There are 2 key surfaces. One is top face is over. Boundary line is dark. Then come to invisible key surface. Invisible key surface edges other than boundary lines are always invisible. That is dotted line. So that is E1 D1, D1 C1 and C1 B1. These 3 are dotted lines. That is invisible lines. Okay. Now let me have clarity. Yes. These are invisible lines. Now think of crossing line or bends. Now I think bends is better here. These 2 lines are dark. Line joining FF1 is also dark. These 2 lines are dark. Line joining A1 is also dark. Okay. Now go for this. These 2 lines are dotted. Line joining D1D is dotted because invisible bends or visible surface invisible line. Till this point you have to draw, but already it is occupied by the visible line. So let us keep this dotted. Normally we forget to do this. Okay. So this completes the solution. Now visible key surface dark, boundary lines also, all boundary lines are dark, invisible key surface other than boundary lines, these are the boundary lines you should not touch, these three are dotted, that is invisible, then visible bends, then invisible bends, invisible, or visible surface, invisible line, invisible surface, visible line. It's a very clear cut procedure. Then you have to, what you have to do, I will give only hint so that I can work on the computer, so that you will get clear idea. Two more cases I take and do it. Before that, let me have this particular point, you project from the both end, this is O1 and O. So you can also have O of B, O of A, O of T sometimes, so that it becomes clarity. This is the base center, this is top center. Now regularly people keep only O over, let us have it. Then draw axis reference. That's all. So this completes the second figure top view. So I will give hint for this so that we can work it on computer software. You easily will get the idea and clarity you will get. Otherwise there will be some changes manually if you do it in this case. Now how to do it? You have to redraw this figure by 45 degree, beta equal to 45 degree. In this case beta is given, that is equal to 45 degree. So what I do is I will redraw this figure so that O1 is on beta degree line. Now I draw a line inclined at 45 degree, that is actually beta. Then I keep, if you want base towards observer, keep O1 O and then redraw it. Geometry should know how to do it, and neatly you have to redraw and then project it up and get the final front view. Now if you want base towards VP and top face towards observer, you take this way, the line lean rightward, okay, down, so that this becomes O1, this is O. So top face towards observer, you will get top face visible in front view. This will work in the computer software. Now let me take a problem on hexagonal prism. We have discussed just now the problem with base side 25 mm and height 60 mm, that is axis 65 mm, 50 mm. Let's with its base on HP. The axis being inclined at 30 degree to HP and appears to be inclined. It is a specific condition. We will discuss that if they give directly 30 degree to HP and 45 degree to HP, what to do. First let me complete this. Now let me have the first position. We are all familiar. If you want, you can write A, B, C, D, A1, B1, C1. Otherwise, the A, B, C, D, E, F is enough as you worked out on the workboard. Then you project it and then get the front view with 50 mm height. This is 25 mm. Okay, some difference is there. Let us assume that this is 25 mm and get the corresponding value. Okay, next comes the, if you rotate, move and rotate, you will get the front view inclined at 30 degree with respect to the axis. So what I did, actually I gave inclination to this. Naturally it assumes, this particular line assumes 30 degree. So then you project unnecessary lines you can avoid by projecting only up to this, because alignment indicator facility is there. You can do only for the required length. Now you name it and join. This is O1 centers. Then keep the, even you can go for the farthest item method or the key surface concept, visible key surface concept, nearest visible key surface concept. That you know, many times I explained. Now after naming all these A1, B1, C1 and A, B, C, D up to F, top face and base, now you start working on the key surface method. Better, because number of lines are there, then it is better to have key surface, visible key surface reference. This is the visible key surface to the observer. That is to be made dark. I have taken purposefully little more thickness so that you can understand. Finally, you have to do 0.5 only, okay, for all the practical purposes. Now, visible key surface is top face for us. This is the nearest surface. So, that should be dark. Basic procedure 1. Okay, basic procedure 1 is visible key surface dark, all edges. Then, boundary lines completely dark. See, keep all boundary lines dark. Then, should look for invisible key surface. How many invisible key surfaces? 1, 2, 3, 4, 5, 6 hexagon. Okay, so 6. Out of 6, 3 already covered by the boundary line. Remaining 3 are there. That is C dash B, C1 B1, C1 D1, D1 A1. All these are dotted lines, invisible lines. So make that invisible. So these 3 are invisible. See, just these 3 are invisible. Now, what you have to do? After these 3 basic procedure, you can think of crossing line or bends. See, these are crossing lines or bends, or visible surface, invisible line, invisible surface, visible line. See here, this is visible surface, this is invisible surface. Line crossing that FF1 is visible because this one is invisible surface. Or you can say the bends here, EF and FA are dark lines. This line joining that corner is also dark. This is visible bends. Okay, it is fact. It is not a thumb rule or any method. So you can easily understand graphically, and also it's fact. This is EF and AF. The AF1 is also dark because these 2 are dark. It refers to this. Now again you can say these 2 are dark, definitely these are also dark. Or you can say invisible surface, visible line. Okay. Now, what about DD1 and CC1? Okay. So again, CC1, DD1, CC1 are connecting to the invisible lines. Definitely they are invisible as per the farthest point. This is the farthest point. Definitely. You can also mix the concept and get confirmed. So validate the information. So D1 is dotted, CC1 dotted, but this portion, particularly this distance between F1 D1 are already, this thing is already covered by the dark line. Preference must be given for visible line. Then only scope is to draw the dotted line from F to D. The line is there. Even if you draw dotted line, it looks like dark line only. That is why we have made preference visible line, invisible line, then axis, then construction line. So C1 D1 is up to this, it's dark. Then this portion is dotted. So what I have to do is FD must be made hidden. Again CA must be made hidden. That is visible surface, invisible line. Okay. So it will continue up to D1, but already that particular line is occupied by, portion is occupied by the dark line, that is not visible, that's all. So now what I do is I will keep this line dotted, only this portion. Even if you project up to, draw up to this, it is not visible. The preference is for this. Now it's completed. O1 is axis reference. So this is how you can do that. Second figure top view is completed. Okay, either farthest point method or the nearest key surface reference. Now, what you have to do here? After this, the O1 is apparent length. So this must be placed on apparent inclination. So apparent inclination itself is given for you. So you move and rotate by given angle beta. Okay, given angle. But geometrically, if you look at this, if this is 45, this C1 D1 is mutually perpendicular to this. Now I can have the question for this same answer. Instead of identifying this as 45, if you take this as 45, C1 D1, if you dimension C1 D1 45, that means true length and true inclination. You can say the base edge on HP, that is C1 D1, that is inclined at 45 degree to VP. We work this type of problems in various shapes like square and square, pyramid, pentagon, triangle, etc. Same type of discussion I can have here. C1 D1 is the base edge on HP, that is inclined at 45 degree to VP. That's all. This is the alternate question. Answer for the same answer for different question. That's all. Now, what I do is, after identifying beta equal to 45, so I have taken only base corners and projected from base corners of the previous front view. Sometimes what happens, people keep these projections and drawn the projection from the top face, they will get different answer, wrong answer. So be careful. I will show that also in future. What happens if you do like that? Okay. Now this is the corner. These are the corners of the base. I have drawn projections from the top view, final top view, and got these points. Similarly, you get the projections from the top face, the projections from the previous front view top face. Join them. Okay, join them. Then join the longer edges, FF1, AA1, BB1, CC1, DD1, and etc. You get the figure like this. All are light lines. Okay, I have made all are light lines. Let us choose a particular method and do it. Now again I have taken the nearest key surface method. The nearest key surface is base. Now base is towards the observer. Here is the observer. Base is towards the observer. It's not visible in top view, but if you look from front, the base is visible. So I have made it dark. Assume that this I have made dark. What is next procedure? Boundary lines completely dark. Basic procedure 3. Basic procedures are there. One is, see that the visible key surface dark, boundary lines are dark, and then invisible key surfaces other than boundary lines are dotted. That we will complete first. First step is visible key surface dark. Yes, it's over. Now I keep the boundary lines dark. Yes. Next comes the C dash, D dash, D dash, E dash, and E dash, F dash are okay dotted lines, because this is invisible surface and these are uncovered by the boundary lines, okay, away from the observer. So see, this is this one. These 3 lines are invisible. Okay. Now, why these are even though the surface is not visible, why these are visible? Because these edges are common to the top face as well as the lateral surface which is towards the observer. The apparent shape of this is visible, you see. Lateral face, if you move up the solid, the lateral surfaces are visible. Definitely they are common, that's why it is visible. So next item is, either you can use visible surface, invisible line concept, very fundamental concept, okay, and join. See, for example, I say AA1 is visible or not. Yes, it is visible because it is crossing the invisible surface. Now this is visible surface. I can even do that shading for the last session also I did. Now let me take this opportunity to shade this with very light surface, if possible. Let us see, because it works for a boundary area, it never works. Okay, maybe some, this one is there. Yeah, problem is there. Okay. Sometimes it is not enclosed, it never comes. That's the problem. Okay. Yes, it has come. Yes. See, this is the visible key surface. Base is nearer to the observer. Base is nearer to the observer. So it is visible surface. So now what about E1E? E1E is not visible because visible surface, invisible line or crossing line, you see. According to our this one, this is visible line. You cannot have the crossing line as same pattern. It is invisible. It is visible means crossing line is always opposite in nature. This must be dotted. Again, what about this? This is invisible area. We have this. Okay, what is that? B1 crossing that. So you can have invisible surface, visible line. Or I can also use this bends. This line is dark, this is also dark, this is also dark. Again, A1 is dark because it is bends. Okay, so you can start with bends, check with crossing line, or even basic concept, invisible surface, visible line. So you can do for all. A1, E1 is visible, invisible because it is crossing line or visible surface. Why I am stressing this point? See, majority of the time people commit mistake. So they give different reasons. They you not give any reason. It is only bends or crossing line or invisible surface, visible line. That's all. Okay. Now take the axis reference. Finally, you have made this sign using this or this. Visible bends, invisible bends, crossing line or visible surface, invisible line. Now, the thing is you have to have the final axis, you project axis also finally. Then this is the final solution for that particular problem. The axis appears to be inclined at some degree to VP. The same problem I can convert the solution into different problem. The base edge on HP, yes, C1D1 on HP, that is inclined at 45 degree to VP. We can take advantage because of the value. This is 45, this line and this line are perpendicular. Definitely this is apparent length, this is true length. So I can say if I dimension to this C1D1, I can write the different question. See, I have written the axis being inclined 30 degree to HP and the edge on HP is inclined at 45 degree to VP. Same answer. See, I have done. We have done this problem many times for different shapes. The base corner is nearer to the observer, okay, and hence base is visible. So that same concept is there. Now, when top face is towards observer, normally we take base towards observer. Then what happens if the top face is? This is very good exercise to get clear idea about the visibility concept and complete the solution. Now, see, this is visible and base is not visible. Now, if you draw complete thin lines, let me again same procedure I have given one by one. You try to follow this. Then top face visible, boundary lines completely dark here. Top face visible, first procedure. Visible key surface dark. See, here I am here. This is the top face. Actually, in second figure top view also it is visible, and third figure top view also, because the same thing is redrawn. And final front view also it is visible because it is towards you. Okay, I demonstrated that when it is towards you, it is visible. Now, boundary lines dark, invisible vertical C surface, other than boundary lines are dotted. Then keep this. What happens? This is invisible bends or visible surface, invisible line, crossing line, bends. You can have three reasons to justify your answer: visible surface, invisible line, crossing line, opposite in nature, and this is bends, invisible bends. Okay. Similarly, you can have the other things like this one. Start with bends, clarify with crossing line, and get confirmed with the invisible surface, visible line. So it's very interesting. You can always use any approach, but don't get confused much because of the methods. Whichever the method, you can clarify with bends and crossing line. That is always true. And also sometimes neither bends nor crossing line works. Only visible surface, invisible line. Invisible surface, visible. That is the fundamental concept that works anytime. Okay. So this is about the hexagonal prism and the respective problems. I have taken you for two problems. One is appears to be inclined at some degree to VP axis, or the base edge is inclined at some degree to VP. Separately here also demonstrated. Now I can have one more problem just like that. The axis is inclined at 45 degree, nothing like appears to be or okay. Now what happened to this axis from O1 to O is apparent length. So find apparent inclination using true inclination 45 degree and the apparent length this you get beta. So definitely you get 55 degree as beta. You can try, and then on that 55 degree you must keep this O1, and whichever the orientation you want top face towards you or base towards you, and get the corresponding final and front view and top view. So that's all about the hexagonal prism. Same concept you can use, procedure you can use for any shape, starting from triangular shape, square, and pentagon, hexagon, anything. Even sometimes you may get rectangular base. So they may give longer base edge on HP or smaller, shorter base edge on HP. You will work out that type of problems also in future. So from next session, we will have some problems on cylinders, cones, and do's and don't do's. So I may take some random problems and then explain what exactly the mistakes you commit in this type of problems.